So from the above results, by observing the previous divisions, we can say that in general, if p of x and g of x are two polynomials, p of x and g of x are two polynomials, such that degree of p of x is greater than or equal to degree of g of x. The degree of p of x is greater than or equal to the degree of g of x, and g of x is not equal to 0. G of x is not a non-zero polynomial. It is a non-zero polynomial. It is not a zero polynomial. Then we can find polynomials q of x and r of x such that p of x is equal to g of x into q of x plus r of x. This is a dividend, this is a divisor, and this is a quotient, and this is the remainder, where r of x is equal to 0. This remainder sometimes we get 0, or the degree of r of x less than degree of g of x, and sometimes we get a polynomial here as remainder. In that case, the degree of this remainder is less than the degree of g of x. Here we say that p of x divided by g of x gives q of x as quotient and r of x as remainder. Understood this step, my little children? Right. Now let us take another example, dividing a polynomial by another polynomial. Okay, my dear children, see here, divide 3x power 4 minus 4x cube minus 3x minus 1 by x minus 1. We have to divide this polynomial by this polynomial. Okay, my dear children, by long division we have what I said in the long division. If you want to divide a polynomial by another polynomial, we have to write the divisor as well as dividend in the standard form. In the standard form means the terms of the polynomials should be in the descending powers of x. So first we write highest power of x in the divisor. What is the highest power of x? X, so power 1 only. So x minus constant. So it is already in the standard form, x minus 1. Now come to the dividend. The highest power of x is 4. Next cube. Next x square should be there, but here x square term is not given. It is missing here. So see here how we are writing this polynomial. 3x power 4 minus 4x cube. Here x square is not given. Here x square term is not given. So in this case we write plus 0 into x square, because this x square term is missing in the given polynomial. That is why we are writing here plus 0 into x square. Understood this part, my dear children? Minus 3x. After x square we write x term. After x term, constant. Now this polynomial is in the standard form. Understood this part, my dear children? Right. Now we follow the steps as we have done. First step, what is the first term of this dividend? 3x power 4 by what is the first term of the divisor? X. Understood this part, my dear children? So 3x power 4 by x. In the numerator we can write it as 3 into x into x into x into x by x. Here x gets cancelled. Then what you get in the numerator? 3 into x into x into x. How do you write it? As 3x cube. So this is the first term of the quotient. This is the first term of the quotient. So we wrote here 3x cube is the first term of the quotient. After that we have to multiply 3x cube into divisor. What is divisor here? X minus 1. So we have to multiply these two polynomials by using the distributive property. So 3x cube into x minus 3x cube into 1. Understood this distributive property, my dear children? Just to recollect the previous knowledge of distributive property. Okay, my dear children. Then 3x cube into x. What will you get here? 3x power 4 minus 3x cube into 1. What will you get here? 3x cube. So we write this polynomial just below this polynomial. 3x power 4 minus 3x cube. We wrote this polynomial. Understood this step, my dear children? After that, you remember this point, my dear children. Don't forget, we have to change the sign of each and every term. Here the first term sign is plus. We have to change it as minus. Here the second term is minus. So we have to change it as plus. After changing the sign of each and every term, we have to simplify. So 3x power 4 minus 3x power 4, the two terms gets cancelled. Then come to these two terms, minus 4x cube plus 3x cube. What do you get? Minus 4 plus 3, minus 1. We don't write 1 before the variable. So minus x cube. Understood this part, my dear children? Right. Then we have to carry down the next term. What is the next term? X square term plus 0 into x square. We have carried down the next term. Then this is the new dividend. Minus x cube plus 0 into x square is considered as new dividend. Understood, my dear children? We follow the same steps again. In this new dividend, what is the first term? Minus x cube. Take minus x cube by what is the first term of the divisor? X. We have to divide the first term of the new dividend by the first term of the divisor. So we wrote this step. Understood this step, my dear children? Right. That is equal to minus x cube means x into x divided by x. Understood this part, my dear children? Right. Here x gets cancelled. Then what will you get in the numerator? X into x square. So minus x square. This is the second term of the quotient. This is the second term of the quotient. So I wrote here minus x square. Minus x square is the second term of the quotient. After writing the second term of the quotient, we have to multiply this term into divisor. So minus x square into x minus 1. As we have done here, we follow the same steps by using the distributive property. Minus x square into x. Minus into minus, what will you get here? Plus x square into 1. Understood this step, my dear children? Right. That is equal to minus x square into x. What will you get here? Minus x cube plus x square into 1. What will you get here? X square. Now we have to write this polynomial here below this polynomial. Minus x cube plus x square. Understood, my dear children? We have to write the polynomial in the next line. After that, again remember the point. We have to change the sign of each and every term. Here minus x cube is there. We have to change it as plus x cube. Here plus x square is there. So we have to change it as minus x square. Okay, my dear children, remember this point. After that, here minus x cube plus x square gets cancelled. Then here 0 x square. Here minus 1 x square. 0 minus 1. What will you get? Minus 1 only. So minus, we don't write here 1. So minus x square. After that, we have to carry down the next term. After x square, what is the next term? Minus 3x. We have carried down the next term, minus 3x. Now this is a new dividend. Minus x square minus 3x is considered as a new dividend. Again, we follow the same steps. Here, what is the first term of this new dividend? Minus x square. So minus x square by the first term of the divisor is x. Understood this part, my dear children? Right. Minus x square can be written as x into x by x. Here x gets cancelled. What will be left here? Minus x. This is the third term of the quotient. I wrote here minus x. Understood this one, my dear children? Right. After that, minus x into, we have to multiply by divisor x minus 1. Again here we use a distributive property. Minus x into x, minus into minus, what will you get here? Plus a sign, x into 1. Understood this step, my dear children? Right. So minus x into x, what will you get here? X square, plus x into 1, what will you get here? X. So minus x square plus x, we got this polynomial. We have to write this polynomial just below this polynomial in the next line. So we wrote that polynomial minus x square plus x. Now you remember this point, my dear children. We had to change the sign of each and every term of the polynomial in the next line. So here minus x square is there, we have to change it as plus x square. Here plus x is there, we have to change it as minus x. Okay, my dear children, remember this point while you are subtracting a polynomial from a polynomial. Okay, my dear children. So here minus x square plus x square, these two terms gets cancelled. We don't get any x square term. Here minus 3x minus x, minus 3 minus 1. What will you get here? Minus 4. So minus 4x. After that, we have to carry down the next term. What is the next term? Constant term, minus 1. Okay, my dear children, this is the new dividend. Consider this polynomial as a new dividend. Okay, my dear children. Again, what is the first term of this new dividend? Minus 4x. So minus 4x by the first term of the divisor, that is x. So if you observe the throughout these steps, we are dividing by x only, not by any other polynomial. Okay, my dear children. So minus 4x by x, that is equal to, in the numerator 4x is there, we can write it as 4 into x by x. Here x gets cancelled. Finally we get here minus 4. This is the next term of the quotient. So here we wrote minus 4. Next term is minus 4. After that we have to multiply minus 4 and divisor. Minus 4 and divisor. So by using the distributive property, we multiply the two expressions. So minus 4 into x, what will you get here? Minus 4x. I wrote here the terms directly by using the distributive property. Minus 4 into minus 1, what will you get here? Plus 4. So we write this polynomial just below this in the next line. So minus 4x plus 4, I wrote the polynomial. Again, you have to remember the point that we have to change the sign of each and every term of this polynomial. Here minus 4x is there, so we have to change it as plus 4x. Here plus 4 is there, we have to change it as minus 4. Okay, my children, remember this point because we are subtracting this polynomial from this polynomial. That is why we are changing the sign of each and every term of this polynomial. Now minus 4x plus 4x, the two terms gets cancelled. We don't get any x term here. Here minus 1 minus 4, what we will get here? Minus 5. If you observe, this is a constant polynomial, non-negative, non-zero polynomial. It is a non-zero polynomial. What is the degree of this non-zero polynomial? 0. Here the degree of this divisor is 1. So the degree of this polynomial is less than the degree of this polynomial. So we stop the division. So this is new division is considered as a remainder. Here minus 5 is the remainder. We stop the division by this step. Okay, my children? Right. So by observing this long division, we get here dividend is 3x power 4 minus 4x cube minus 3x minus 1. This polynomial is dividend, and the divisor is x minus 1. This polynomial is divisor, and 3x cube minus x square minus x minus 4. This polynomial is quotient, and the remainder is minus 1. So we can write this fact in the form of this equation. Dividend is equal to divisor into quotient plus remainder. We substitute these four values in this equation. What is dividend here? 3x power 4 minus 4x cube minus 3x minus 1 is equal to what is divisor? X minus 1 into what is quotient? 3x cube minus x square minus x minus 4, and what is a remainder? Minus 5. Understood this point, my dear children? Right. So in this example, if you observe here, the remainder is minus 5. Here the remainder is minus 5, and 0 of x minus 1, this is a divisor. If you find 0 of this polynomial, it is 1, because x minus 1 is equal to 0. You know how to find 0 of a polynomial. This is a procedure. So x minus 1 is equal to 0. This implies x is equal to 1. So 0 of this polynomial is 1. So we got here 0 of the divisor, that is 1. So putting x is equal to 1 in P of x is equal to 3x power 4 minus 4x cube minus 3x minus 1. So this is a dividend. So in this dividend, in this polynomial, if we put 0 of this divisor, we see that here we see that P of 1 in this polynomial we are substituting x is equal to 1. So P of 1 is equal to 3 into 1 power 4 minus 4 into 1 cube minus 3 into 1 minus 1. Understood this step, my children? Right. That is equal to the value of the first term is 3 minus the value of this term is 4 minus the value of this term is 3 minus 1. Understood this step, my children? Right. 3 minus 4 minus 3 minus 1. What will you get here? Minus 8. 3 minus 8 we get in this step. Understood this step, my dear children? Right. 3 minus 8. What will you get here? Minus 5. If you observe, this number is nothing but the remainder. So without using the long division, we can find the remainder when a polynomial is divided by a linear polynomial. Throughout this exercise, we divide a polynomial by a linear polynomial. The steps, see the steps, we have to find the 0 of the linear polynomial, 0 of the divisor, and we have to substitute that 0 of the divisor in the dividend in that polynomial. Then we get some value. That value is nothing but remainder when the polynomial is divided by a linear polynomial. Understood this point, my dear children? Right. Start correct. Okay, my dear children. In the previous examples, we have observed some points. How to divide a polynomial by a linear polynomial. In the last example, we have verified the remainder by substituting the 0 of the linear polynomial in the dividend. Okay, my dear children? Right. Now come to the statement of remainder theorem. Let P of x be any polynomial of degree greater than or equal to 1. Let us consider P of x is a polynomial of degree greater than or equal to 1. And let a be any real number. Let us consider a be any real number. If P of x is divided by the linear polynomial x minus a, here we are dividing this polynomial P of x by this linear polynomial x minus a, then the remainder is P of a. So without using the long division, we can find the remainder when a polynomial is divided by a linear polynomial. This is the advantage of the remainder theorem. Understood, my dear children? Let us take some examples to understand this concept very clear. Okay, my dear children, right. Now let us take an example to find the remainder when a polynomial is divided by a linear polynomial with the help of remainder theorem without using the long division. How to find the remainder? See here, find the remainder when x power 4 plus x cube minus 2x square plus x plus 1 is divided by x minus 1. Here they asked the remainder when this polynomial is divided by this linear polynomial. Understood the question, my dear children? Right. Let us consider the polynomial is p of x. P of x is equal to x power 4 plus x cube minus 2x square plus x plus 1. Let us consider the given polynomial is p of x. And let us find the 0 of this linear polynomial. Let us find 0 of x minus 1. How do you find 0 of a polynomial? We have to equate the polynomial to 0. We have to write this equation. Given polynomial is equal to 0. We have to solve that equation. Then what do you get here? X is equal to 1. This is called 0 of this polynomial x minus 1. What you got here? 1. So we have to substitute x is equal to 1 in p of x is equal to x power 4 plus x cube minus 2x square plus x plus 1. We have, then we get p of 1. In this polynomial, we have to substitute this 0 of this polynomial. We got here 1. Understood, my children? So p of 1 is equal to 1 power 4 plus 1 cube minus 2 into 1 square plus 1 plus 1. Okay, my children, we substituted x is equal to 1 in this polynomial. Now we simplify these terms. 1 power 4. What is the value of 1 power 4? 1. Let us find the value of each and every term separately. Plus, what is the value of 1 cube? 1 only. Minus 2 into 1 square. What is the value of this term? 2 only. Plus 1 plus 1. Understood this step, my dear children? Right. Now 1 plus 1, 2 plus 1, 3 plus 1, 4 minus 2. 4 minus 2. Understood this step, my dear children? What you get here? 4 minus 2? 2 only. So this number is called remainder. So by the remainder theorem, 2, this number 2 is the remainder when x power 4 plus x cube minus 2x square plus x plus 1 is divided by x minus 1 without using the long division, and with the help of the remainder theorem we found the remainder. Understood this example, my dear children? Right. Now let us take another example. See here, check whether the polynomial q of t is equal to 4t cube plus 4t square minus t minus 1 is a multiple of 2t plus 1. Here in this question they did not use remainder, the word remainder or the remainder theorem. They did not use the words remainder or remainder theorem, but this question is based on the remainder theorem. Okay, my dear children, understood the question? We have to check this polynomial is a multiple of this polynomial or not. Come to the solution part. As you know, p of t, this polynomial will be multiple of this polynomial only if 2t plus 1 divides q of t, leaving remainder 0. If you divide this polynomial by this polynomial, if you get remainder 0, in that case only we can say that it is this polynomial is a multiple of this polynomial. So indirectly here we have to find remainder. Indirectly we have to use the remainder theorem. Understood, my dear children? So we have to find the 0 of this polynomial. To apply the remainder theorem, we have to find the 0 of the linear polynomial. So what is the linear polynomial? 2t plus 1. So 2t plus 1 is equal to 0. This implies 2t is equal to minus 1. We are transposing plus 1 to RHS. It becomes minus 1. So 2t is equal to minus 1. This implies t is equal to minus 1 by 2. So here we got 0 of this linear polynomial. What is the 0 of this linear polynomial? Minus 1 by 2. We have to substitute minus 1 by 2 in the given polynomial q of t. So put t is equal to minus 1 by 2 in q of t is equal to 4t cube plus 4t square minus t minus 1. Then we have q of minus 1 by 2 is equal to 4 into, in this polynomial we are substituting t is equal to minus 1 by 2. So 4 into minus 1 by 2 whole cube plus 4 into minus 1 by 2 whole square minus of t minus 1 by 2 minus 1. Understood this step, my dear children? We have substituted q in the polynomial q of t, where t is equal to minus 1 by 2. So we simplify each and every term separately. So 4 into minus 1 by 2 whole cube. See here, I am finding here separately minus 1 by 2 whole cube value. Minus 1 by 2 whole cube means minus 1 by 2 into minus 1 by 2 into minus 1 by 2. Minus into minus plus, plus into minus, minus. So finally we get minus 1 into 1, 1, 1 into 1, 1. So in the numerator we get minus 1. By in the denominator 2 into 2, 4, 4 into 2, 8. So in the denominator we get 8. So minus 1 by 2 whole cube value is minus 1 by 8. So I substituted minus 1 by 8 here. Minus 1 by 2 whole cube value I wrote here. Understood this term, my dear children? Right. Now come to the next second term. Plus 4 into minus 1 by 2 whole square. Minus 1 by 2 whole square value we are finding here. Minus 1 by 2 into minus 1 by 2. Understood this part, my dear children? Right. So minus into minus, what will you get here? Plus. 1 into 1, what will you get here in the numerator? 1 only. By in the denominator 2 into 2, what will you get here? 4. So finally this is the value. 1 by 4 is the value of minus 1 by 2 whole square. So we are writing the value of this minus 1 by 2 whole square, that is 1 by 4. Understood this second term, my dear children? Right. Now come to the next term, third term. Minus of minus, what will you get? Plus. Minus into minus, plus only. Plus 1 by 2. And last term we write as it is. Understood these terms, my dear children? Right. Now we simplify each and every term again. 4 into minus 1 by 2. 4 1 times, 4 2 times. Then what will you get here? Minus 1 by 2. Plus 4, 4 gets cancelled. Here what will you get? 1 only, second term. Plus 1 by 2, I write third term as it is. And minus 1, I am writing that fourth term as it is. Understood this step, my dear children? Right. Here minus 1 by 2 is there. Here plus 1 by 2. These two terms gets cancelled. Here plus 1 is there. Here minus 1 is there. These two terms also gets cancelled. Finally we get here 0 by simplifying these four terms. Understood, my dear children? So this is the nothing but a remainder. What you got here? Remainder 0. Okay, my dear children? Right. So finally we got here remainder 0. So the remainder obtained on dividing q of t by 2t plus 1 is 0. Without using the long division, we got here remainder 0. So 2t plus 1 is a factor of the given polynomial q of t. That is, q of t is a multiple of 2t plus 1. Both sentences give the same meaning. Understood, my dear children? Right. So in the exercise 2.3, there are only 3 sums. Can you do the sums in the exercise 2.3? I am not explaining the sums in exercise 2.3. I have explained the concepts and I explained some examples on the concepts. Okay, my dear children? Will you try the sums in exercise 2.3? will you complete the exercise 2.3? Only there are 3 sums. Okay, my dear children, in the next class I will start the concepts in exercise 2.4. Okay, my dear children, right.